Hello, welcome back to Cracking the Cryptic, and I absolutely love the design we see on our screen. You may not get it until I tell you that the puzzle is called Cube Roots of Pi by Blobs. But look at the mathematical symbols involved. So each of the light blue lines is a cube sign. The superscript 3 that you would put on a cube root is there for each of them. And it is cube rooting pi. Now, I don't know any maths. Well, sorry, I know some maths. I don't know enough maths to know if the cube root of pi has any significance in mathematics. It certainly has some significance in this puzzle. I love that Blobs has found an arrangement of numbers in a Sudoku grid that allow him to put in these three perfectly spaced cube roots of pi diagram into the diagram. It's fantastic. Anyway, I don't know, maybe I get overexcited about grid achievements like that. If you ever tried to conduct a Sudoku, especially based on a sort of pre-limited pattern, you will know why I'm impressed. That is very cool. Obviously, some cages have been added. I'll get to the rules in a moment. I'm looking forward to it, as always, with the Blobs puzzle, so reliable. And of course, Blobs created March's Sudoku Hunt, the Patreon reward for the month, which is the Nurikabi puzzle pack. So check out our Patreon. That's where you'll find that, along with crossword videos, connection videos, all kinds of other stuff. And it's a great place to join. $2 or $3 a month. It's really not a lot, is it? Anyway, there's also our apps for either $4 or $6 a go. Fantastic value for hours of entertainment and just improving your brain as well, as of course it will do if you try this puzzle on screen or just watch this video. It will improve your brain. But the apps are brilliant. The latest is, well, we have Line Sudoku and we have Killer Sudoku, but we also have Fog of War, which is our latest one. The grid's clear as you enter correct digits. It's just marvelous fun, designed for interaction, Fog of War. And of course, we've got our merchandise linked under the video along with SVEN'S SUDOku PAD. The latest item in our merchandise is Amber Pitcher's marvelous t-shirt design, which quite a few people have bought already, I'm delighted to say. Thank you very much. I love to imagine a world in which people are walking around advertising that they watch Cracking the Cryptic. It's brilliant. Anyway, let's look at this puzzle, go through the rules, and then attempt the puzzle, see how we do. The normal Sudoku rules apply. So 1 to 9 will go in every row, every column, and every 3x3 box. We don't often start with a 3 in the corner, but we do today. Now, the blue lines, box borders divide blue lines into segments with the same sum. So that group of cells will equal the same total as that group and that group. Along a pink line, digits form a non-repeating consecutive sequence in any order. So this could contain 3, 4, 5, 6, 7 in some order. This one might be 1, 2, 3, 4, 5 in some order. Now, each cage has a sum that is a perfect cube. A cube, obviously, is a number multiplied by itself and by itself again. A power of 3, if you will. And obviously, Blobs has come up with a disambiguation technique that involves cubes, which is very relevant. Well done. So give it a try on that first link under the video. You can judge from the video length potentially how hard it is. I'm going to start now. Let's get cracking. Well, let's start with the cubes, because surely the only relevant cubes are the cube of 1, which is 1, and the cube of 2, which is 8. We've only got 1 and 2 cell cages. We can't reach 27, which is the actual cube of 3. So that must be a 1-8 pair. These are either 1 or 8. Actually, that's a 1-8 pair in the bottom row as well. And these two must add up to 8. This one doesn't have a 3 in it. So it's either 2, 6 or 1, 7. Actually, the same is true of this one, because there's a 3 in the box and the column. That's even more obvious. I mean, that's a fair start, isn't it? I don't think I've done anything wrong. Okay, what I would normally have done with a blue line is found a blue line which had a single cell to map against a group of cells. So that digit has to be, well, I was going to say 6, 7, 8 or 9 because it's the sum of 3 different cells. But those 3 cells can't include a 3, so they're at least 7. 1, 2, 4 is the minimum. So I think we go 7, 8, 9 there. This, of course, the disposition of this cube sign, this root sign, across the boxes is different. It means the one cell on this end is hanging out the end. So that is 7, 8 or 9, as we know that these can't include a 3. Now, since they can't include a 3, they must include a 1, because they can't be 2, 3, 4 equals 9. So there must be a 1 there. And that means this cube cell contains an 8, this one contains a 1, this one contains an 8, and now this total can't be 8. There must be a 1 in that group. I mean, I suppose by the same token, there must be a 1 in this group as well, and we know where it goes, because we've got a 1 there and a 1 there. The 1 goes here. Now, there can't be a 1 in this cage anymore. It's a 2, 6 cage. This pair of cells adds up to 8 because of the blue line rule for this line. And I'm just worried I've missed something about the cube things. I don't think I have. That is either 1, 7 or 2, 6. Again, it can't involve a 3. Now, if it's 1, 7, the 1 can't go there. This group of cells adds up to 7 or 9. If it's 7, it's a 1, 2, 4 set. If it's 9, it is 1, 2, 6. Ooh, that would be very fillable in, wouldn't it? Well, I don't know. It's 1, 2, 4 or 1, 2, 6. I think the same is true of this region and of this region. No, we could add up to 8 here, so that's not true. This could be 1, 2, 5. There must be a 2 on this, is that right? It's either 1, 2, 4, 1, 2, 5 or 1, 2, 6. Yes, the simpler way of looking at that is that any 3-cell segment of different digits that add up to the same as 1 cell in a Sudoku, I learned this a long time ago, must have 2 of the very low digits, must have 2 out of 1, 2, 3 on them. And if you think about all the combinations, you'll work out that that is true. This one must have 2 low digits on, but it can't include 3. So 1 and 2 must be on there. Now we know that this isn't a 2. That's a 6. That's a 2. This cell is not 6. For some reason I marked 6 in the corner. I didn't mean to do that. It's also not a 2. So that is 1 or 4. This can't be a 1. One of these must be a 1 because this line needs a 1 on it. And there's a 1 there, so the 1 in row 3 is over here. Oh, I should have thought about this. Yes, this is very straightforward. I just didn't think about it. So, this group of cells is either 1, 2, 4 or 1, 2, 6. It definitely includes 1 and 2. This group of cells, they're all different from each other, but they don't include 1 and 2, but they are a sequence. So the lowest they could be is 3, 4, 5, 6, 7. Note the digits I'm emphasizing. The highest this group could be is 5, 6, 7, 8, 9. So 5, 6, 7 is always on this Renban. And now 6 can't be in this group of cells, and they must be 1, 2, 4 equals a total of 7. So we can get rid of 6 out of those two. This end of the line equals 7 as well. Now 4 is not on this line, and it must be a 5, 6, 7, 8, 9. And that becomes a 3 in the box. It's the last digit left over. So, 7 looks at that cell. There is a 3 in one of those. That's not very interesting, but it is true. 5, 6, and 9 are the digits remaining in the top row. Now this group can be 1, 2, 4 or 1, 2, 5. It cannot now be 1, 2, 6. So it either adds up to 7 or 8, and those are the choices left here. Now again, these add up to 7 or 8. I was going to write a 2 in here, but that's not valid. Because if they add up to 8, this could be 134. So it's either, and it could be 125. So we just don't really know what that segment of line is, but we're getting on very well with the other segments. Still got one cube cage left to decide. Right, where do we turn for help next? 1, 3, 8. I don't know what's going on there. That could be 8. I'm not quite sure what to do next. Let's have a look at this line. Oh, right. Yes. This line adds up to 8, and that's 3 cells. That must include a 1. So now we do know the last cube cage. So this is either 134, in which case that's a 3, or it's 125. I don't think it's obvious to me which it is. Ah, 8. Look at 8. 8 is ruled out of all of those cells by Sudoku, so it's there in box 7. That's an easy spot that I just didn't make. So we've got 125 there. Now this line, now I see it cannot be a 125 line because that digit can't be any of them. So it must be a 143 line. And actually I could have used that to work out. This was unable to be a 9 already, wasn't it? I think. Yeah. So I could have worked out that this wasn't a 7 line by saying if that was 124, that digit couldn't be any of those. Anyway, we get there in the end. There's an 8 in one of those 2 cells. We've got 7, 8, 9 left to post in this row. Let's just keep going. Bit of Sudoku, that's a 3. Now, stop doing Sudoku, start doing Renban again. That is on, right, we can't have another 3 on the line, so there's a 3 in one of those cells. There is a 3 in one of these 3, which looks likely to be on the pink line there. Anyway, let's go back to this. Once you've got a 3 on a 5-cell line, you're going to have to put 4 and 5 on it. The other 2 digits then are either 1, 2, 2, 6 or 6, 7. I'm just talking about the possible sequences. The trouble is I don't know which side of that 3, the 4 and the 5 go. And that's a pencil mark I don't really want to make across a box border. So I will leave that in abeyance for now. Now, are there reasons that we can't have a 3 here on this line? It's quite interesting to note that 1 and 2 cannot appear on these cells. 1 and 4 cannot appear on these cells. Maybe it's not enough though. Okay, let's just do Sudoku. That can't be a 1. That can't be a 1. That can't be a 4. These can't be an 8. We need another 1 or a 2 in this column. It's so likely to be there. Can I rule out 5 from there? Yes. Yes, I can. Yes, I can. Okay. I'm going to do it in a very simple way now I've thought of this. So this line is 5 cells long. It's a Renban pink sequence line. It has to have a 5 on. If you think of the runs of Sudoku digits, they start with 1, 2, 3, 4, 5, and they end with 5, 6, 7, 8, 9. They all have a 5 on. We've got this 1, 2, 5 triple. That says that although there's a 5 on this line, it can't be in box 9. It must be in box 8 in one of those cells. And now this digit cannot be a 5. In fact, those 2 can't as well. Now, the reason I'm getting excited about this is because this digit, which is on a line that sums to 8, can't be 5, 4, or 3. It must be 1 or 2. And that forms a pair with this digit in the column. And now these that have a 5 on also have a bigger digit. We don't know whether it's 6, 7, or 9, but we know it's bigger. And I've got completely overexcited about that. Don't know why, really. Yes, I do. Yes, I do. This line cannot have an 8 on it. Look at that 8. That's ruling out all of those cells. This one is ruled out by 2 different cells. So there's no 9 on the line. It now must be, I think it must be 3, 4, 5, 6, 7. These digits can't have a 2 in because of the 1, 2 pair, and the 2 is forced out of those. So if it can't have a 2 or an 8 on, it is 3, 4, 5, 6, 7. Those ones aren't allowed to have 5 in. 9, but they must have a 3 on the line. So we know it's not here, and now we know it's not there. One of these two is a 9, because we need to put a 9 in the box, so that's not... we need a 2 in this box somewhere, and we know where it is now. And now we know this digit is a 4. It sees the 1 and the 2 in the column. 4, 3, 1, 2. So these are higher than 1, 2, 3, 4. Oh, that's really big for this. This is not only in a group of 5, 6, 7, 9 in the column, it's in a group of 1, 2, 3, 4, 5 on the line. So that must be a 5 as the overlap point. Then we put 1 and 2 on the line. I was about to announce that this line adds up to 8, but we've known that for an awful long time. Now, this line has got a 3 on. It's a Renban. It can't have a 9 on. That's too far away from 3. So it's got 6 and 7. Now it needs 4 and 5 to bridge between the 3 and the 6, 7 pair. And now we're in business. We've got a 4, 5 in this column. That can't be 4 or indeed 7. 4, 5, 7, 8. We need a 9 in this column in one of those 2 cells. And therefore this isn't a 9. And now this is a 9 in row 1. These 3 have become 5, 6, 7 by default. Okay, these include a 4 in one of those 2 cells now. And therefore the 4 in column 9 must be in one of these 2. Still going to pencil mark this to death. We need a 4 and a 9 in box 5 in those 2 cells. So that's not 9, they're not 9. 4, 9, 1, 2, 3. This is from 5, 6, 7, 8. And it can't be 8. Weirdly, it looks like there's only one place for 9 in this box. It can't be in any of those cells because of that 4, 9 pair. And this line can't have a 9 on. So it is there, just checking the logic there. So then I can fill in 7 and 8. Now 9 can't be in that one, nor can 6 or 7, nor can 5. In fact, this is an 8. 8 can't be there. What does that teach us? That teaches us about 5, 6, 7 triple in row 3. That makes this a 9. So in this row 3, we've got 5, 6, 7, 3, 9. That places 9 in box 3. These are from 1, 2, 4, 8. That one sees a 4, 5 pair and an 8. So that's 1 or 2. Yeah, there's a lot done in this column now. Because that can't be 5, so it's part of a 1, 2 pair. That's a 6. That's a 3. Still got a few 1s and 2s to sort out. That can't be a 2 anymore, though. In this row, we were having 1, 2, 4, 8. 8 must be in one of these 2 cells. I don't know which one yet. So let's switch back somewhere else. Where are we looking? I'm not sure. Okay, I don't know. Let's look in this box. 6, 2, 4, 5. 3 is in one of those. These are from 1, 7, 8, 9. I don't know. 1, 2, 5. We've got a 9 into one of those. Right, 9 in this box must be in one of those 2 cells. So these are from 1, 7, and 8 now. Oh, look, that 2 is looking at this cell. That's quite a big deal. 1 there, 2 there. This can't be 2, so this can't be 6. That 2 is looking up to the top. 1 and 2 there. That digit in this column has to be there. So 6 or 7. That's a 6, 7 pair in row 5. In row 5 we've got 6, 7, 2 and 3 placed. That's a 4, 5 pair. So these must be from 1, 8, 9. But that doesn't mean this is 9 because that could be a 1, 8 pair. 9, 3, 8, 6, 7, 1, 2. That's 4 or 5 by Sudoku in the column. Ah, 7 is looking at that cell. That's quite big. I should have spotted that a while ago. Right, that's going to get stuff done. So that's 6 and 7 in the column makes that a 5. That places 5 in this row as well. 5, 6, 7, 8, 9. These are from 1, 2, 3, 4. Not interesting. Back to this column where we can place 2. There. These are a 4, 9 pair. That gives me a 4, 9 pair in row 6, which makes this a 5. 4, 9, 2, 6, 8, 5. Remaining digits in the row are 1, 3, 7. Not quite resolved. That is 4, 5 or 9, I know. Oh, getting bogged down again. 1, 4, 5, 6, 8, 7, 9. This is a 2, 3 pair. I can fill them in thanks to the 2 in column 8. That's become a 1 now. This is now an 8, 4 pair, and I've got a 4 being in one of those cells, so I can resolve them. That 8 comes out of that cell. Let's just look down this column. 3, 8, 2 are placed. That can't be a 3. 4 is down here somewhere. Is there only one place for 5? No, incorrect. Right, let's look in this box. That is not allowed to be 1 or 3. It can't be 9 because 9 is down here somewhere. So that is 7 or 8. Then in the row, I've got 4 or 7 here. Oh, that row doesn't finish off. I need a 5 in one of those 2 cells now. Have I finished with the lines? Pretty much. Oh, not quite. I have to make sure not to repeat here. Oh, that's quite interesting. Look, I don't think this can be 6 or 7. Because where would that digit, so this yellow digit has to go in the bottom row somewhere. I mean, that's a knowledge bomb, but it must go somewhere. If it was 6 or 7, it would be ruled out of those cells, but it would also be ruled out of that for being on the same line. So that wouldn't work. That cannot be 6 or 7 because it can't go over there. So this yellow digit must be a 4. That's very neat. I like that sort of deduction. Now we get a 4, 5 pair here, which rules 5 out of this cell and puts it definitely here. Now, that has become 6 or 7. This has become 9. I've got some pairs forming in the bottom 3 rows. I was going to list the types, but I'm not going to. I thought that was that neat thing with the 4 was going to finish off the bottom row. It didn't quite do that. I've only got one place for 3 in this row now, so I'm going to fill that in there. This can't be 9 according to the 4, 9 pair, so I'm placing 9 there. That 3 hasn't done anything special. Oh, that can't be a 2. So I've placed 2 in column 7. 1, 5, 6, 2, 3. I'm having to look along the rows again, just when I didn't think I was going to be doing that anymore. Now I find myself pencil marking every cell with all its possible digits. I've still got this Ren band to finish off, but that's going to fall out automatically. Oh my goodness. Right, let's just approach this systematically. That's not a 5, so one of those 2 is. Oh, look, I've got a 9 looking at that cell. Well, that's really quite big. It's big information. That just does it all, just fills it in for me. If only I would spot when things like that are going on. I mean, there must have been some counterpart that I could have spotted somewhere else in the grid, because these things don't come single spies, as Shakespeare used to say. 6, 5, that's 6, sorts out all the remaining 7 6s, and we're done. Just like that. And not too hard a puzzle. Nice fun from Blobs with the cube roots of pi. And really an excellent solve. Most enjoyable. Not very difficult maths, thank goodness, with the cubes having to be found despite the appearance of the grid. Great fun. Thank you as always for watching us on the channel. It's an absolute privilege to have your company, and we hope you'll come back tomorrow for a bit more variant Sudoku fun with Cracking the Cryptic. I've been Mark. Goodbye for now.